Let's look at problem 6. Problem 6 says, interferon beta 1b, beta-seron, is prescribed for a client with multiple sclerosis. The person is to receive 8 million international units SC every other day. Each vial of powder contains 9.6 million units. The directions are: add 1.2 milliliters of 5400% NaCl to vial, so that's a sodium chloride solution, and 1.2 milliliters equals 9.6 million units. How many milliliters will you administer for each dosage? So here we have a situation where we have a drug that has come to us in a powder form, and the first thing we have to do is follow the directions to reconstitute that drug. In other words, make it now into a liquid that can be injected into the patient. So we first have to take 1.2 milliliters of water, 1.2 milliliters of a sodium chloride solution, a 54% strength one to be exact, and inject that into the vial. We would then shake that up to dissolve the powdered interferon in the solution. And once we do that, we have then a strength that says there, for every 1.2 milliliters of now the liquid that we have created, there are 9.6 million units of the drug. So that's now the strength of the liquid. It contains 9.6 million units in 1.2 milliliters. Those are the milliliters of the sodium chloride solution that we put in order to reconstitute the drug. Now, our patient is to receive 8 million international units. That's how much drug we are to inject, but we're going to be injecting it as a liquid, so we need to know how many milliliters do we need to inject. Well, we have right here an equivalence we can use. We need to have millions of units to cancel, and we need to end up with milliliters, so we could put milliliters in the numerator and million units in the denominator, and it said that 1.2 milliliters of the reconstituted solution contains 9.6 million units. And actually, 9.6, just to make sure we understand, when it says 9.6 million, that's really what? 9,600,000. That's 9,600,000. And of course, 8 million units would be 8 followed by 3 zeros. But since the units are the same, millions of units, we don't have to convert our numbers to the full representation of millions, but we could do the problem that way if we wanted, because that's what 9.6 million actually means. It means 9,600,000. 8 million would be written that way if we wrote it out in full length. But we really don't need to do that. And when we multiply, it's interesting, 8 times 1.2 gives us 9.6, and 9.6 divided by 9.6 would say we need 1 milliliter of the solution. We would, after we reconstituted that solution, we would draw out 1 milliliter of it and inject it into the patient. Then they would be receiving the 8 million units of the interferon that they were to receive.